All right, I guess it's time we can get started. I guess the first reminder is that the OpenZFS Developer Summit is coming up soon. That'll be October 16th and 17th in San Francisco. The call for papers is open now. Matt would like everybody to get their abstracts into him before September 5th so that we can build the schedule for the conference. Okay. Right now, the agenda looks like it's all my stuff, but I hope other people have stuff to add. But the first item that we have is some work we're doing on Z for Linux, specifically to extend the work we did a couple of months ago, where you can, using per Dedup properties, configure Z as far as the number of IO or checksum errors within a set amount of time triggers the auto spare of the device. We're now extending that so that you can do the same thing for slow IOs. So if a particular disk has too many slow IOs in a set amount of time configured with the VDEV property, then ZFS will automatically replace it with a spare. I think we've all run into the situation before where one disk was dying but not quite dead and was dragging the performance of the entire pool down based on it. So if Z can detect that and automatically swap in a spare if you have one, then that will get the performance of the pool back easily.
Alan, will that work with the RAIDZ spares?
That's a good question.
Yeah, I forget
think
the logic.
Conceptually, but yeah, that's something we hadn't thought to look at. That's a good point that I will have to have Rob dig into. Anybody else see any gotchas with that other than DRAID?
No, I'm thinking there would be nice to have opposite protection if, for example, some indeed single disk, but affects whole SAS fabric that happens quite regularly and makes problems for many disks same time. It would be good to not activate in that case, because attempt to rebuild while we are not sane in general, it would just make things worse. I'm not exactly sure how to formalize it, but would be definitely good. So we would not try to go beyond pool redundancy and beyond pool stability.
Yeah, if the number of disks that exceed the threshold is more than the number of spares, then just do nothing kind of thing, right?
Yeah. Right. Or generally more than one or something. Like I don't know what the chance for more than one disk fail at a time. So if we have problems with more than one disks, then maybe we shouldn't make rapid movements.
Exactly. I think that makes sense. Okay. And then in a related one about Z, we're also looking at improving the logic around if you pull a disk out of the enclosure and then put a replacement disk in the same slot. On Linux, depending how you had the device named, if it was named by the WWN or anything like that, then Z says, this replacement disk isn't the same and doesn't do anything. And so we're looking at extending it to look at the enclosure path, the enc path property, if it's not null, so that, if it's the new disk is in the same, enclosure in the same slot, then consider that a replacement for the disk that's missing and start the replace automatically rather than having to be triggered by a person. So right now it only looks at the actual device path, and we would extend it to, if that doesn't match, but the enclosure path does, then maybe that's the right answer.
ZFSD on FreeBSD doing that, I think Spectralogic implemented a number of years ago.
ZFSD does exactly that.
Yeah, so it would be good to have logic to be the same, I think. On the other side, I'm just slightly worried of extra replacement. On TrueNAS, we never used that logic, and it was just normally blocked by the fact we are partitioning disks, and FreeBSD ZFS never partitions disks, so it effectively protected us from unwanted activity. I just thinking how would it be controlled on Linux? I don't want things to be replaced arbitrarily.
Well, I think you might have to opt into the Z rule and like activate that specific one. And in general, there's a bunch of safeguards like, is the disk that's coming in blank? Then it's okay. But if it's, if it has a ZFS label on it, we're not going to clobber that and destroy your data.
Right, because that it prevents you from accidentally slotting the disk into the wrong slot. It's like, oops.
No, yeah, I like the idea to have it opt-in. So just user who configures the system should know what he's doing and how it should behave. I just don't think it's using it by default is a very good idea. Well, just maybe not intuitive for users.
Well, especially, everybody's enclosure is different and whether they even have the enclosure stuff to have a path there and so on. But yeah.
That reminds me, at some point there was a question whether paths on FreeBSD and Linux are actually the same. Originally, they came from Lumos, and some people complained that Lumos Solaris format is pretty weird, and there was a wish to improve it. I don't remember where it ended up on FreeBSD. I have a feeling somebody was working on that, on changing that format.
This is the ENC path one?
Yeah.
I think on FreeBSD, it's literally like the dev enc with the thing with all the comments, it's like the SAS path, basically.
No, not dev enc. I'm speaking about property of that we write into labels that FIS path.
Right.
That enc ends WWN of enclosure / blah 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 long unreadable string.
Yeah.
There was some activity to recently change it on FreeBSD to make it more reasonable and readable, but it would break compatibility with previous pools. From that perspective, that makes me wonder, like, what are we going to do about those paths? Do we already have them different between different platforms? Because originally FreeBSD mimicked Solaris or Lumos, so there was at least compatibility on that front. But I never knew what Linux does on that enclosure path, how it looks there.
Yeah, so the enc path that we were looking at for this is, I don't have the example in front of me, but it is very Linux specific. I'll have to pull it up on a FreeBSD machine as well and see what I think it doesn't even get populated on FreeBSD right now, which might be something to fix.
Just if you take any enclosure with SES, you should get that path.
Right.
If you get any HCI, FreeBSD emulates HCI emulates virtual enclosure for HCI ports.
Yeah.
So any SAS disk on modern system should have an enclosure path.
Okay.
Physical path. So you should find it without problems. The question of whether it matches or not.
Yeah. Don, did you want to provide an update on the RAIDZ expansion stuff?
Sure. Yeah. I'm looking for reviews still. So anybody out there wants to contribute and help get this across the finish line, that would be helpful. There's a few Z-test asserts that I'm still chasing down with Fedora. So, but they're kind of rare, so I'm not as concerned about those. And then I had a question about the FreeBSD side of things. When I do commits, it doesn't look like any of the test bots run against FreeBSD. Is that, do you have to opt in?
Recently.
Or just the builders are down, or?
I think that was part of the problem. Because I noticed this on, I forget which recent pull request didn't end up getting run against FreeBSD either. Yeah,
because I did a recent change, which is FreeBSD specific. So I really want to see a bot run the test suite. So I added detection for the BTX bootloader on MBR. They use that.
They're stashing the
bootloader in that little spot. Fortunately, there's a header there, so it's easy to detect. But I want to make sure I have a CFS test suite for that to make sure that you get the negative test on that. So, and then the other question was code coverage. We don't do code coverage anymore on Linux. I know that FreeBSD has code coverage capabilities, so I don't know if there's a way to opt in to like for FreeBSD side to do code coverage. It would be nice to get code coverage numbers, but
For the BuildBot stuff, you might check with Tony Hutter. He's been doing some work on that infrastructure, so maybe he accidentally broke something.
okay. Yeah, I just noticed it wasn't doing any FreeBSD runs, and specifically after I made the change. So
Yeah,
I'll follow up with him. Thanks, Matt.
But yeah, I've seen the same thing on another recent pull request. And hopefully we can get that fixed.
Oh yeah, recently we had FreeBSD here and 13 to test it, at least 2 versions, but I haven't checked lately. Speaking about RAIDZ, I wonder about timelines. Like if it's approaching, it's to be implemented. I guess it's already too late for any 2.2, and it probably won't be merged since it introduces new feature flags for that. Just my sales team attacks me regularly, like when when we see it. And,
I think yeah, the big gating item here is just getting the reviews, and I know it's a big wad of code, and that's just the challenge. So.
Oh yeah, a review, it's understandable. It's more like, will it be like only 2.3 and will be some release sometime next year? Probably no sooner. We'll see it.
that seems likely. Brian, who isn't here, could probably comment more definitively, but I would probably recommend that we not try to stick it in at the last minute into 2.2. But I will take a look at the code review probably later this week.
Okay. I noticed Pablo's on the call. I don't know if you would be available to look at it or look at portions of it. And I think
maybe that's possible.
okay. It's fairly straightforward actually. And if you watch one of Matt's talks, it sort of outlines the high level, approach. Okay. Oh, that's all. Pretty much all I had.
Yeah. So I have an update on the fast dedupe work we've been doing. Maybe spend a few minutes on that. The kind of results we have so far are actually pretty interesting. So just quickly share that. So the first thing we noticed was the recent commit to master that changed the default indirect block size and block size for dedupe from 4K to 32K, and looked at the impact that had on write inflation. So this is all just normal dedupe in master, and noticed that, with the block size equals 12 or block shift equals 12, you can see the blue line there, that as we wrote more and more data to the pool with dedupe, the amount of inflation, or the amount of writes we had to a dedicated dedupe VDEV went up as we got more objects. But obviously you see with the higher block size of 32 or is that 16? Yeah, 32 or 64K, then we see much higher inflation, almost double. So that change, while making the DDT itself quite a bit smaller and more compressible, does actually have the effect of making the write inflation, especially with small blocks in dedupe, much worse. But that also made it easier to compare with log dedupe and see what the mitigations for that were. The other main difference that explains some of the reduction in amplification you see with the work we're doing is the change to the actual on-disk structure of DDT. So it uses a new set of zaps with a feature flag and will only activate if you didn't have traditional dedupe on. But in traditional dedupe, each entry in the DDT had 4 DDT fizz-Ts. So it could store the list of DVAs for a normal single copy dedup, a copies equals 2 and a copies equals 3, and then it had the deprecated slot for the ditto block. So that means it actually had room for 12 full DVAs and ref counts and birth times, making each entry quite a bit bigger and mostly full of zeros, and that's why each entry is separately compressed with ZLE before it's actually put into the DDT. We replaced this with some new code that has just the one set of 3 DVAs, but has the ability to update the existing dedup entry if the new block coming in has a higher number of copies. Then we'll allocate just the one extra DVA and update the entry to have the existing single DVA and the new second DVA. The only downside of this is if you free the only one that had copies equals 2, the dedup will not free the extra copy. So we'll have the most number of copies you ever had of a block until the block has references equal to 0 and gets freed entirely. But I don't think people really change the copies equals around that much that it's going to be a big impact for people. And if you asked for 2 copies at some point, then you asked for this, and that's just how it's going to be. But this way we save 3/4 of the biggest part of each DDT entry. And then we implemented the first version of dedup log. So as new changes come in, we write them to an append-only log and maintain the list of what those changes are in a separate in-memory AVL tree. Then once that log reaches its some criteria, we're expecting a maximum size or age, then it will condense that log, basically truncate that log after writing out all those changes to the ZAP. And the idea is that this would hopefully amortize the cost of using a larger leaf and indirect block size like we saw in the first slide there. Right now, the prototype isn't that smart. All it does is condense the log every n transaction groups, but it was enough to be able to show what the performance impact of that is. So to test this, we ran FIO on a data set with a record size of 8K, chosen mostly to allow us to get a large number of dedup entries without having to write a huge amount of data, but better performance than we got with trying to do it with 4K, so we get better throughput. All the blocks are completely randomized, so they fill up the unique DDT. There's no actual dedup happening here. This is just the worst case of 100% unique data being written. So we write out, make a new data set and write out 4 2-gigabyte files to it. So we can use a couple of threads to write basically 8 gigabytes of data, which would create about 1 million DDT entries. Then we stop and measure how much data has been written to the dedicated dedup VDEV in the pool. And then we export and import to reset that to 0, create another data set and write 8 more gigabytes, and did this a number of times in iteration to show how it affects performance over time as the dedup table gets bigger and bigger. So here we see in blue and red, the first 2 lines, those are the existing traditional dedup code. Red being the previous, where each leaf is 4K, and the blue is where each leaf is 32K. And you see, like the first graph, that big difference in the amount of write inflation. Then at the bottom, the green line is the fast dedup code, where it's writing to a log and then updating the ZAP. Both the log and the ZAP live on the dedicated dedup device, so all the log writes are included in these numbers. So just batching up 32 transaction groups worth of writes and then updating the ZAPs incrementally once every 32 transaction groups, you can see greatly reduces the amount of write amplification. Doing it every 256 transaction groups, you can see has this kind of spiky effect of every time we do it, there is a bunch of extra data to be written out. And something smoother might make more sense. We're also looking at ways that we can basically time limit how much time we'll spend updating the ZAPs during each transaction group so that we don't drag out the flush time for a transaction group.
Alan, can I ask a question about this?
Yes.
So 32 transaction groups is not that
No,
long.
This is a small
yeah, I know this is, I just want to understand like
yeah.
why we see it not to, I know you have more work in mind, but I would think that, even aggregating 32 transaction groups at a time, given that you're doing random writes, you would still have like every leaf block of the zap would have only one update to it, right? Because it's fully randomized in terms of where it's being updated, unless the DDT is very small. I would
Right.
think
So this
that,
is starting with the DDT at 0. So at the first point here where you see 8 gigabytes written, that's about 1 million entries in the DDT. And so each increment here is adding an extra million entries in the DDT up to 10 million.
so do you think that what's happening is that the DDT is so small that like that you're fully rewriting the DDT and you're getting multiple like entry updates in each leaf block of the DDT each time, or is it one entry updated per DDT leaf block, and it's only the indirect blocks that we're seeing a benefit here?
Definitely seeing the benefit in the leaf blocks as well, because there aren't that many in the end when you're at the smaller size. When we looked at just ZDB on the DDT on the zap at the end after the 10 million, there was a decent skew of birth times where not every block in the zap had to be updated each time.
Yeah, I guess maybe it would be interesting to see how this, like 80 gigabytes written is like not probably is not that big compared to the challenging use cases. So it'd be interesting to see this go up to like terabytes, and
yeah, for sure,
and see like if there's some discontinuities in those lines.
Yeah, this was just the first cut to tell if our prototype was doing what we thought it was doing.
Got it.
Because yeah, like we've got some data from a couple of real world Dedup customers that have 320 million objects in their Dedup table, and it's like, yeah, at that scale things are going to be quite a bit different. One of the things that this work is hoping to do is by using the sharding of the zaps that we will further concentrate and make it slightly less random. So part of that is either sharding on the physical block size, so doing that in 4K increments or something, because even just doing every 4K increment from 0 to 16 megabyte being the max record size would be 4,000 shards. But it means that if you have a block that's 1.4 megabytes, then you only have to search that zap of blocks that are that size to find if the hash is already there. And also, if you're concentrating your updates, then when you're flushing one of these logs that contains only the updates to 16K blocks, then you're writing a much smaller zap, and hopefully it's less random and you get more concentration, so that again you get more of this amortization effect.
Yeah, I think that the goal here is to, when you're fleshing out the changes, to have multiple updates go into each leaf block, right?
Yeah.
So I think that would the optimal way to do that would be to have all of your changes sorted by hash value, and keep the most that you can, and then write them out into the DDT by hash value.
Yeah.
Right. So like you're writing out over many TXGs, and like in the first TXG, you're writing out all the ones that have like hash prefix 0000. And the next one, you're writing the ones with hash prefix 0001 or whatever, so that you're concentrating your writes. And then like, since you can do this over multiple TXGs, you can kind of like do it continuously. So you're like, okay, like my memory limit is I can use like a gigabyte of RAM for these like pending changes. And then like, once I get close to that, I just start, eating through writing out by hash value and keeping like a cursor of where I am. That way you have like the densest set of modifications like right in front of your cursor, because that's the oldest part. And then you can kind of like determine the like feed rate just based on the memory usage, or some like minimum values.
Exactly. And it's kind of similar what I was saying about kind of like we do with Scrub and so on, is like we want to spend this much of each transaction group fleshing these out or whatever.
Yeah.
When it does
I think that if you do that, that's going to give you kind of the optimal behavior, and you don't really need any additional like sharding. on top of that, because you aren't like,
Possibly, yeah.
you mentioned like, oh, like we separated out so we don't have to search, but since it's a hash table, you're not searching at all.
Right. Yeah. So yeah, we'll look at that. This is basically the same data, but looking at the write throughput, and we see that, as the zap gets bigger, that does have more and more effect. Part of this is we were purposely exporting and importing the pool between each of these runs. So we're starting with an empty arc each time. Also, this was a relatively small VM whose arc was not going to be able to cache the whole DDT anyway. But seeing the effects of the different stuff, we still see quite a big improvement. But I think, like Matt said, some of the ways we can amortize most of these costs can end up making a big difference and allow us to take advantage of being able to have larger leaf blocks so that it's more less fragmented, and we get better prefetch and so on Dedup as well. Sorry, that was that. Other thing we noticed is that right now we store all the DDT zaps as copies equals 3, which makes sense, especially, the duplicate zap is, you could never free a block ever again if it was damaged without knowing, if you could decrement it properly and so on. But the unique zap is different there. With the dedup prune concept, we'd be able to go through the unique zap and delete some entries to make room to keep the size of the DDT from getting too big, especially to make it fit in memory, or at least constrain it to the size of your dedicated dedup VDEV. So there's already changes to the freeing code to not, assert that we can find that hash in one of the dedup tables. So with that, it means that if we happen to damage the unique zap table, that it wouldn't be catastrophic to the pool. It would mean that, if we lost the whole zap, it would mean that, new writes wouldn't have a good chance of deduping against the old blocks, but the pool wouldn't lose any data or anything. If we reduce the number of copies we store the unique zap with to 2 or even 1, that would basically cut the write amplification of all those zap updates down by a lot. Are there other things we need to be concerned about if we do something like that?
I think that's a great idea.
Because just looking at real world use cases we've seen, even with customers getting dedup ratios of like 3.5 to 1, they still had like 240 of their 320 million records were unique. And that's a lot of stuff to store 3 times, just takes space, but also every time you're writing one, you're writing it out 3 times. Writing it twice or once would be.
Or when you're when you're pruning entries, or presumably could lose them here, have you changed the way that scrub works so that it can still scrub these blocks that have the dedup bit set? Because normally scrub ignores, like when it's traversing the block pointers, it ignores ones that have the dedup bit set, and it scrubs them by finding them in the dedup table.
No, I don't think we did that in the previous version of it.
Yeah, so I think that even to handle the freeing or like evicting things from the unique zap table, you need to like change the way that scrub works. Presumably like have scrub, actually look at the blocks of the dedup bit set, and then go look them up in the dedup table. And
if they're not there, then pretend like the dedup bit's not set, basically.
Yeah, well, or basically like if they are in the duplicates zap, then you don't scrub them. But if they're in the unique zap, then you do scrub them.
Right, and then don't have to visit.
Or if they're not in any zap, then you do scrub them. And then you have to worry about like blocks that transition between one or the other zap.
Right.
Like if it can go from unique to duplicate and then back from duplicate to unique, then you'd have to worry about that. But if it can only go from unique to duplicate and then never goes back, then even when there's one copy, then you might be able to simplify that.
Yeah. Because also I think this will have a big effect on the dedicated Dedup VDEV. You can fit more DDT if you're not writing 3 copies of all the blocks to your dedicated VDEV. And 3 copies on the same VDEV is not as helpful as if, you know, the way copies normally works for regular blocks, it would try to spread those copies across different VDEVs. But when you're using an allocation class, it's going to put all 3 copies on the special VDEV.
Or VDEVs. You could have multiple.
Yeah, you could have multiple,
VDEVs.
yes.
It'll spread them across them.
Mm-hmm.
I mean,
So I have a question. So I like the idea of not doing copies 3 for the Unix app, but also like the biggest problem from my tests was how much we have to read during when we sync transaction group, because of the hash is random, so we have to read all the indirect blocks. So I was actually wondering if it wouldn't be better to have a single DDT and just read once, like one large one, instead of just looking into 2 different ones for the entry, because that multiplies the number of reads, and reads are of course synchronous during transaction group, so that slows down transaction group. So wouldn't it be better to actually have a single one?
So not have the unique and the duplicates be separate?
Yeah. Because for to look up each entry for like large DDT, we need like 4 or 5 reads per entry.
Right.
And we are doing this during transaction group sync. We cannot prefetch. We can only prefetch for frees, because for free we do have hash. But for RAIDZ, we cannot do prefetching because we don't have hash yet. So during transaction group, if we have 2 zaps, we have to do the reading twice to try to find the entry in each of them.
Each zap, yeah.
Yeah, I think that you would be able to do them in parallel, but like you would clearly, like having 2, if you have 2 giant zap objects and you need to look in both of them, then you're doubling the number of disk accesses for RAIDZ.
Because if you double the size of DDT, you won't double the number of reads. Maybe you will do 1 extra read or something like that.
Well, I mean, if the dedup table, if you multiply it by 1000x, then you do 1 additional read, right?
Yeah,
because you're adding
exactly.
1 more layer to the indirection.
Exactly.
Well, it's not 1000x because the indirect blocks are smaller.
Okay.
But yes, it's like 32x
But it's
or
not
whatever. But
2, yeah.
My biggest concern with that is it takes away our ability to reduce the copies equals on one of the zaps.
Yeah, I mean, you might consider like maybe reducing copies to 2, just like for all DDTs, or like having, maybe like, because I feel like it's pretty it's not super necessary given how people configure their pools. Like the copies stuff was neat when you're thinking about a non-redundant pool, and adding a little bit of redundancy for very little cost. But in this case, the cost is high, and probably people are using this with like RAIDZ or something, some type of redundant pool that's like they care about their data and they've configured it to be redundant enough that they aren't going to lose data. And the case of like single block, you'd only worry about this when it's like, I've lost the maximum number of disks, I haven't reconstructed yet, and then I also lost 1 random block randomly, and then like that happened to be a dedup block, which was important, and now the additional copy really saves me. Which is hopefully not that common.
Yeah.
So I would think that reducing it to copies equals 2, just like for everyone
board,
all the
yeah.
time, would be fine.
Mhm.
And then like maybe think about, could you reduce it to, like, if you reduced it to copies equals 1 for everyone all the time, what would the implications be? Like, could you not lose data, but just leak stuff, right? Because we're only really worried about like losing access to like 1 or like a small number of blocks of the dedup
Mhm.
table. And so if we could write the code such that, yeah, if you lose like 1 block of the dedup table, then what's going to happen is whatever was referenced there is leaked forever.
Yeah,
But
it just
that's going to be like
that
a small
conflicts
amount of
with
space.
the concept of dealing with, we couldn't find this hash in the dedup table, so it must have been a copies equals 1 or a ref equals 1 that we purged.
Well, you'd have to know, like, oh, if we can't read this, if we can't determine whether it's in the dedup table or not,
Right.
then we have to assume that there are still more copies of it and not free it.
Right.
But if we can read the block that it should be in, and we find it is definitely not in the dedup table, then you can still do the
Right. Yes. Okay. So yeah, if we read and we got back ent, it's okay. But if we get EIO or whatever, then we leak the block on purpose or whatever.
Yeah, exactly.
Or we don't free it and it might end up leaked or might not.
Yeah.
Yeah, I think that doesn't
Can't we
risk a lot of
detect
space.
that? Can't we detect that we have redundancy in the pool? Like if there is RAIDZ, we use copies equals 1, and if this is a laptop and we have only 1 disk, we'll use copy equals 2.
Sure.
Yeah.
Could do that.
Possibly, although, if you're using dedup on your laptop, you might be in trouble. But
I have
that's
64
not
gigs.
unreasonable. Yeah.
Anyways, I think that it would be nice to preserve the only needed to look in 1 zap for performance reasons, because that's like, double your performance right there, versus having to look in 2 zaps.
Because like there's not really a difference in the on-disk format of those, that like the entries aren't different or anything. So I don't think they are. Do you know why there were 2 separate zaps originally?
I don't remember.
Okay.
My recollection was that there was some performance issue around that originally, but I don't remember the details anymore. It's a long time ago. It's been this way since I think almost the beginning when Jeff first did this stuff.
Yeah, because the only other use case we've done before for a different customer, because dedup prune didn't exist at the time, was like at import, drop the entire unique zap with a flag. So if you set a flag while importing the pool, we just dropped that entire zap and truncated it and made a fresh one. And so you'd only have your blocks that were already deduped to dedup more, but it got the size of their DDT for in memory down a lot. And just doing that occasionally seemed to make dedup work well enough for them. But if we're gonna have real dedup prune where we can walk through the tree and clean stuff up, then I don't think we need that separation anymore. But we'll experiment with it and see if that if we find out why it was originally split up. Because the advantage with the sharding is because it's deterministic, you only have to look in the shard, a specific shard ever, so you're not ever having to look at more. But I think, especially if we're going to shard, not having to have 2 of every shard would help on our side as well and make the code a bit easier to deal with. So we'll investigate that as well.
Alan, do you have any numbers on how this dedup log impacts reads during transaction group sync? Because I'm not concerned
there
with the
are
writes.
no reads. Yeah, so while entries exist in the log on disk, they also exist in an AVL tree in memory. So you would never have to read from disk if the hash you're looking for is in the log. It will always be in the AVL tree in memory.
Yeah, but I'm more concerned that because you have the log and you are not really writing the updates to DDT every transaction group. So every 32 transaction groups, when you try to sync the AVL3, you will need a large amount of reads. So you will have like spikes in the reads. So it would be nice to see, because like this, every 30-second transaction group will take much longer, for example, than all the rest.
I'm assuming that this once every 32 is prototype only.
Yes, it is just prototype.
I think if you take the approach that I outlined of like, you have some limit, and then you for the size of the AVL tree, and then you have a cursor of like, this is the last the hash value that I wrote out, and then like every TXG you walk forward a little bit, writing some of the entries, but those are the entries that are all with the most similar hash values. Then that way, that's the way that you're going to get the most likely to have consolidation of modifying the same block of the DDT,
right?
Multiple entries being in the same block of the DDT.
Right.
And because we would know the hash range ahead of time, we could also prefetch all those blocks to deal with Pavel's concern as well.
Right. And you could be adaptive as well a little bit and say, well, we're not keeping up, so we may have to traverse more of that range than the previous.
Yeah. So like, you make sure that you limit the size of the AVL tree and also have some minimum amount of progress, right?
Right. Or just like a high watermark. When we're above this mark, we're going to try to write some out and make sure that we don't ever hit the upper limit.
That's interesting, because we could also like limit how much AVL3 we sync by monitoring how much reads we did and how much we slowed down the transaction group sync. So for
that's
example,
why I was thinking in particular, like Scrub, limiting the flushing of the log to some number of milliseconds per transaction group.
I mean, but you have to limit the size of the AVL tree, right?
Yes.
Don't have you have a finite amount of RAM.
Right. And because this AVL is basically over, it's not in the arc like the DDT is, we can't page it out. It's like this memory is locked down. And so, we have to have a limit.
All in all, it's great to see DDT Dedup being worked on. So I think everyone is happy.
Yep, definitely. I just like from experience of Metaslab, process log Metaslab during pull import, I'm thinking it would be good to not, like, if we can flush more of Dedup, if load is low, somehow we can, if we could flush it more often, to not accumulate too much in log, to not replay it during pull import.
Yep.
So just a wish.
Yeah, that's definitely one of the things on our radar, is making sure that, especially for HA failover and so on, that the import time can't get too out of hand, because that'll not be useful to anyone. And so again, that's why I was thinking, if we'll spend up to this much time each transaction group, or at least this much time each transaction group, fleshing things out, then we can, like Mav says, keep the logs from getting too big, so that at a full import we don't have to read a lot of them to play stuff back. Were there topics anyone else wanted to talk about?
I don't know if you already covered this, but the developer summit is coming up soon. And we would love to hear about all the great work that folks are doing. So the deadline is in 3 weeks, September 5th, to submit a talk. Some of the things discussed today would be great to hear about at the conference. The Dedup work, the RAIDZ expansion work. So send me an email with your proposal of what you'd like to talk about. And then the conference will be October 16th to 17th in San Francisco. Any questions about this year's conference? All right, that's all I have.
I think the next one I had on the, go ahead, Matt.
Yeah, I would like to bring once more attention to my second attempt to refactor ZIL writing and ZIL locking. In previous attempt that is currently committed and merged to 2.2, George found deadlock caused by the fact that there is no way ZIL can sleep or block or anything like that after it allocated next block, or it may be a deadlock at the end. So in my patch in PR 15.122, I once more refactored the code with the idea that everything that everything that may sleep or block or things like that should be done before the allocation. It also in a way makes code cleaner, because I previously tried to avoid those scenarios explicitly one by one until I found it's impossible to do it for all of scenarios. So it's slightly bigger refactoring and slightly more complicated state machine, but I believe it's much cleaner at the end. And since there are known deadlocks in the previous implementation, I'd like this to be, if possible, review it and merge it sooner and hopefully get into 2.2. Even so, George so far is the only one who reproduced deadlock on his workloads. Still, I am not very comfortable about that. So comparing to previous ones, this also removes a few more operation out of ZL issuer lock, so it should be even more scalable than a previous one. So it adds a couple more atomics, a couple more locks, lock and locks, but I haven't seen any more contentions, more or less contention. So looks good to me, much better than previous, but needs a look. Josh promised to run some tests on it this week. But if anybody else can take a look, I would be happy.
I'll have Rob Norris from my team take a look at it for you. He's done a lot of digging in the ZIL lately, trying to deal with disks going away and what that means for the ZIL. The one other one I had on my list here was, oh, I was going to put that in, okay. Looking at, we already have per user quotas, but there's some interest in per user reservations, so that you can make sure that, if you have a data set for a class at a university or whatever, that while the students can use up the whole quota for the data set or whatever, making sure that the professor has a reservation so that they will always be able to write, the last couple of gigabytes of space in that data set are reserved for that user. Has anybody else seen other use cases where something like that might be valuable, or predict any complexity in trying to implement something like that?
My first thought was it was contradictory to the whole idea of over provisioning, but once you mentioned professor, like some higher priority user, it kind of makes sense.
Mm-hmm.
I just it comes to my mind that somebody also asked for possibility to do some reservation and quota not on a physical level but on logical level, because like if you are giving somebody promised somebody you can write 100 gigabytes, you probably mean 100 gigabytes of logical size and physical. But yes, I may be scary with amount of additional numbers we're tracking, reporting, allowing to configure just number of knobs growing exponentially.
Yeah. Yeah, I've definitely seen people asking about, logical quotas instead of physical quotas, so that, if the data happens to compress, that's the advantage of the owner of the pool, not the user. They can only write 100 gigs of logical data or whatever. But yeah, it's trying to think about the interactions between, a user quota, a user reservation, and then maybe a project quota and the data set quota and reservation. It's like that's a lot of math to do to figure out how much free space there is in the data set. But I just wondered if other people can think of use cases for that, or if there would be enough demand for a feature like that to make sense.
I would guess we would have to not load full table of all the users. We would have to have some cumulative summary, total number. How much do we have reservation for all the users that we could add to data set level reservation? Actually, should it go on top or overlap? Like how those?
Yeah, that's the other thing is like, should the sum of all the user reservations not be able to exceed the quota of the data set? So and it gets.
Or how should
really
it interact with reservation of a data set?
Exactly.
Not,
a lot of questions.
Not currently, but historically, when I ran a number of multi-user systems, we ended up working around not having that by basically just having a data set per user for their home directories and then just giving each of those a reservation. So I think there's certainly probably demand for it. I don't know if there's enough demand to warrant the complexity, but.
Yeah, at this point, I was just doing this thought experiment of how much complexity there actually is there. I think that's all the ones that I really need to get to today.
Nobody else has anything. I'll ask for thoughts on the PR I opened like 4 hours ago.
Which one is that?
I opened one that adds a threshold for the 12.5% compression threshold. That upper bounds it at 12.5% of 128K. Not because I think that's the optimal one, but just as a starting point to discuss what a good setup for that was. And I got several different people's comments so far on what should be done there. I was curious what other people's thoughts might be on that, because I'm going to go collect a bunch of data on when this would be useful, but the data is only going to be as good as how constructive the thoughts I have on it are. I figured that just starting at that much of an upper bound would be a reasonable start, because that way you don't have to say save 2 megs to compress a 16 meg block. If I recall how the math works, right?
That reminds me of I have to clean it up and upstream it, but we've developed compression equals slack, which just trims off trailing zeros when you have a like record size equals 16 meg and your file is 20 megabytes and you have compression off because say the file's already encrypted or whatever. Currently you end up you're writing out a whole bunch of zeros at the end of that block because compression is off. And so compression equals slack just takes the trailing zeros off the end of the last block and can really improve the write throughput of files that are not divisible by the record size, especially if they're if you're writing a bunch of 17 megabyte files to a data set with record size equals 16 megs, you end up writing practically 40-something% zeros to your disk, and it really hurts your throughput.
Cool. So like a faster ZLE that you just apply to the last block of the file.
Well, it doesn't even do ZLE. It just sets the physical size to end where the logical data does. And then it just, inflates this, doesn't have to inflate the zeros back because the logical data is only that long.
Great.
Can you do something similar for embedded blocks? Because embedded blocks are currently also, we try to compress them.
Embedded blocks are the result of compression. If you compress the data and it compresses down to less than like 108 bytes or whatever, then we just stuff it in over the checksum and other spots in the block pointer.
Yeah. But because of the metadata of the compression algorithm, you can actually write much less. Well, much less.
Yeah.
Less than you could otherwise.
They're saying you'd apply this trailing zeros compression first and then normal compression, and then
I
maybe
guess-
that
I
helps it
guess-
to fit into
Embedded.
a block pointer better.
If you're going to do that, you'd probably also want to use various options for like LV4 and Z standards to skip a bunch of the header data, which you know you don't care about because it's tiny frame anyway. But I don't know how much that would save you in practice. So when you're only getting 110
Yeah.
bytes or something.
But I remember from my tests when I was just writing some small random blocks, I could actually fit like 20 bytes less in the embedded block because of that we tried to
like
compress.
with LZ4, we even outside of the compression header, we have a ZFS header of the original logical size. That's like the first 8 bytes or 4 bytes of the data and so on. And so, yeah, there could be opportunity to get more data into embedded block pointers, especially if people had, 100-byte files.
I mean, at least for LZ4, the reason you need that is because it doesn't have one the way that we're storing it. So, and it doesn't make any promises if you give it too large a block.
Right.
Because I think the logic there is that we first have to expand to the whole record, and then we compress, and then we try to fit into embedded block.
Yes.
Something like that, right?
I don't think anything logically requires that it get inflated that large, which was what I was going to ask.
That's basically, I don't remember all the details now because it was a couple of months ago when we wrote this. But I think part of it is avoiding some of that inflating it to the full size because, why copy a bunch of zeros around in memory if we're not going to write them down?
Yeah. That was.
And in particular, trying to avoid doing that as well when recreating it on the other side. So when we decompress, we don't need to fill memory with a bunch of zeros just to throw them away when we return the data to user space, and it's only going to be the original logical size.
You get to apply this optimization to all compression algorithms or just the special Slack setting?
Right now, it's just the special Slack setting because the customer's like, we want compression equals off because we don't want to waste CPU time on LZ4 on encrypted data that's not going to be compressible. But when we switched our record size from 128K to 16 meg, suddenly we were losing a lot of space and we were seeing worse performance because we were spending all this time writing out zeros on all of our randomly sized objects.
I guess philosophically, is there a reason it couldn't apply to any compression setting that's not off?
I don't think so.
Okay.
Anyway, we'll get that cleaned up and get a pull request open and we can discuss it further there.
Right.
I had almost forgot that we did that. Too many things happening at once.
Often a good problem to have.
Yep.
But yeah, if anyone has any other clever thoughts on when we should threshold compression, because requiring you save 2 megs for a 16 meg block seems like a bit much. Thoughts and comments welcome. I will.
Yeah, I think that threshold was definitely come up with when the 128K was the max record size.
Yep. I have some previous experimental data that's close to about the optimal threshold below a certain point, but I'm going to go collect a lot more useful data shortly.
Yeah, I think we're at time here. So thanks, everybody. And we'll When's the next one, Matt? 4 weeks?
Should be 4 weeks from now. September 12th.
I'm back at the normal later time.
Yep. Cool. See you all then.
See everyone then.
Take care,
Remember to
guys.
submit your talks.